Looking at number 5 on the Volumes of Revolution or by Revolution worksheet. Natural log of x. Y equals 0. Okay, I know what y equals 0 looks like. At least get that one. X equals e. Do you remember what e is approximately equal to? 2.7 something? And natural log looks something like that. It's because the natural log of 1 is 0, and the natural log of e is 1. So there's our base area. Base, axis, reflect, and draw the circles. So the axis is the x-axis. Probably our favorite axis to rotate around. Reflect it. And then draw some circles. So this is a 3-dimensional bullet looking thing. Disc or washer? Disc or washers? Disc. There's no holes in there. It's a solid all the way through. So no little r, just a big R. I'm going to jump down to the volume thing because I like to think about dx or dy because that determines a lot of stuff. Are these stacked? Are my discs stacked along the x direction, or are they stacked in the y direction? They're stacked in the x direction, which means my limits need to be in the x direction. So am I going 0 to 1 or 1 to e? 1 to e. And now I just need to figure out what r is, big R. Okay, well it's changing. That's the first thing I note. So it's not a constant. It's going to have a variable in there. Natural log of x. It's tracking along with the height of natural log of x. So r is natural log of x. And this is okay for showing your work. It's okay to have r in that expression because you've defined what r is. Now when it comes to the calculator, I guess this is where we should be careful. This is okay to leave as an answer, but to put in the calculator, you'd have to put natural log of x in there to get the answer. All right, part B. So it's the same shape, the same base as part A. It looks different because the scales are different. But it's still, there's the natural log of x, x equals e, and y equals 0. So there's our base area. Rotate around the y-axis. So our axis of rotation is the y-axis. Reflect it over.
You gave me the wrong test.
Give me the wrong one.
This is 4A, and I need 4B.
Sketching our picture. Base area, axis of reflection, reflect it over, and then draw the circles on there. we go. Disc or washers?
Washers.
Definitely washers.
It's supposed to be recorded. Yeah, I thought it was.
Pi. Washers means big R squared minus little r squared. Are they stacked up in the x direction or stacked up in the y direction? In the y direction. So what are my limits going to be? Zero to 0 to 1. Add up all the little washers from 0 to 1. Big R? What's big R equal to? Well, first of all, is it constant or is it changing? Big R is constant, so it's the outer edge of this shape. It's constant and it's E. Little r is changing. The something minus happens when your axis of rotation is not on the x or y axis. So I don't think it's going to be anything minus. Is it an x value or a y value? Is it left and right or up and down? The little r. Yeah, it's left and right, so that's x. But I need it to be in terms of y. So if y equals natural log of x, how do I figure out what x is equal to? Got to do the loop-de-loop thing. E to the y is equal to x. So little r is e to the y. And then now you'd be ready to put that in the calculator. One more. So base area, same as all the others. The line x equals e. Oh, this is a little bit tricky. I'm not sure exactly how far. If I'm rotating around E, then I think I'm just going to eyeball this and see if it matters later. I don't know exactly where that's going to land over there. Pi integral, we're stacking them dy, and disc or washers? Are they disc or washers in there? Yeah, they're all discs. There's no holes. They're all solid circles. Any slice. So NA for little r. Big R, it's changing. It's not constant. But measured from E rather than measured from an axis, so I need to be a little more careful here. And we said x was equal to e to the y. I want to know how long R is, how long this piece is. How am I going to figure that out? What's the full length from the y-axis to the axis of rotation? E. And so how do I figure out what R is? E minus e to the y. And then those disks are stacked up from 0 to 1. Lots of pretty pictures.